Now if you understand the graph of y versus f of x and the idea of the derivative, you can easily find the equation of a straight line. Okay, basically, if you know a point on the graph and its slope, you know that you can find the equation of that straight line. And the way you do that is very simple. If your point is x1, y1, then y minus y1 over x minus x1 is the slope from the known point x1, y1 to the general point xy, where xy could be any point in the plane, but we're going to write a relationship down that ensures that xy will be on the line that goes through the point x1, y1 with the given slope. So this expression here gives us the slope from the xy point to the x1, y point. Y minus y1 is the rise, x minus x1 is the run. And that has to equal m, which is the slope of the line. If this slope is equal to the slope of the line, then the point xy is on the line. If it isn't, then the point ain't on the line. Okay? Now, this simple relationship can be rearranged to give you y minus y1 equals m times x minus x1, which is one familiar form of the point, the point slope form of a straight line. Or if somebody wants to really complicate the issue, y equals m times x minus x1 plus y1. A straightforward rearrangement adding y1 to both sides. And as I say, this complicates things because the further you get from this, the less this looks like something that relates a very specific slope to the slope of the line. And that's more complicated. This is an easy idea, an easy picture. This is just a formula that doesn't mean much of anything. And some people will even expand this, although that's kind of unusual. You get mx minus mx1 plus y1. Well, nobody memorizes it that way. I would say this is the most common form. And this one is fairly obvious because if you divide both sides by x minus x1, you get the slope, which has to equal m if m is the slope. Okay? So, we establish that it's very easy to find the equation of a straight line if you know a point on the line and the slope. And I said a slope. I really should call that the slope, because there's only one slope on a straight line. Okay, now how does that get us to the tangent line? Well, I'm going to detail that a little more, but it gets us there because if you have a function y equals f of x, and you know a value of x, which I'll call x sub 0, I could have as well called it x1. If I have some value of x, then I can plug that in to find the corresponding value of y, and that gives me a point on the graph. We call that x naught, y naught. That's a point that lies on the graph of the function. Now, we also know recently, in most cases, but maybe a little further back, how to find the slope of a tangent line at a given point. So what's the slope of the tangent line? At the point where x equals x naught, in other words, at the point x naught, y naught, or x naught, f of x naught on the graph, it's the derivative, f prime evaluated at x naught. So that's a pretty straightforward idea. And then, knowing the coordinates of the point and the slope, you can easily find the equation of the tangent line because you just put the coordinates of the point in here instead of x1 and y1, you would use x0 and y0. It doesn't matter what the subscript is, as long as this value of y goes with this value of x, okay? And in place of the slope, well, you put the slope, which is f prime of x0 in this case. So you have a way of getting the coordinates of the point, something you've known for some time, even if you're just taking this course, just starting this course. And now we understand that you have a formula that's derived from the difference quotient. Remember that the difference quotient just represents a slope or an average rate of change. Take the limit of that difference quotient and you get the slope of the tangent line, the instantaneous rate of change, the instantaneous slope. Using these two quantities with this, it's really easy to find the tangent line. Now, tangent line has some properties that are a little more challenging, but finding it is very easy. So we'll do that in a couple of examples in the next video.